All right, welcome back to our discussion. Today we're going to finish up talking about horizontal asymptotes today. And horizontal asymptotes and limits are kind of nice. They kind of go very well together for us. And these, like I said, are going to be pretty easy to do. So in the case of a horizontal asymptote, we are looking for what happens to the value of a function as x either increases without bounds or decreases without bound. In other words, going to negative infinity. In pre-cal, we call this in behavior. There is a shortcut which we'll talk about later on today. In the meantime, let's learn how to actually solve these. So a lot of times people wonder, well, who thinks of techniques like this? Well, somebody does. Somebody very smart thinks of these little techniques. I wouldn't be able to, but a lot of people do. So let us look at this function, this rational function here. We want to determine what happens to the function as x approaches infinity. In other words, we would like to solve the following limit. To solve this, we divide everything by the highest power of x. And this is a lot of work. So this says the limit as x goes to infinity. And if I divide everything by the highest power of x, that's just 4x to the fourth. I'm going to divide everything by x to the fourth. So I would get this 3x squared over x to the fourth minus 3x over x to the fourth plus 7 over x to the fourth over 4x to the fourth over over x to the fourth, minus 3 over x to the fourth. And I'm going to clean this up a little bit here. We'll see what happens. The top here, this just becomes 3 over x squared minus 3 over x cubed plus 7 over x to the fourth. On the bottom, we would get 4 minus 3 over x to the fourth. Now, before we can move on, we have to come up with a rule for us. Right up here. We have to come up with a quick little rule. What happens if we take the limit as x goes to infinity of 1 over x? And that's not too hard to think about, right? If I take a look at a calculator right here, let me see here, whoops. If I take a look at like 1, if I divide it by 10, I get, 1/10, let's put that as a decimal. If I take 1 divided by 100, I get 0.01. 1 divided by, let's say, I'm going to go crazy, boom. Wow, we get smaller. It gets closer to 0. So as x gets really large, this gets closer to 0. Matter of fact, this right here is really how we define a horizontal asymptote, as the limit as x goes to infinity of a function. That infinity part is what defines a horizontal asymptote because we're looking at the end behavior of a function. Remember, as x goes to infinity, that deals with the end of a graph. So once I know this little rule right here, I can actually kind of make short work of this. Because if 1 over x becomes 0, well, what does 3 over x squared become? 0 a lot faster. 3 over x cubed becomes 0. Matter of fact, the entire top just becomes 0. Well, let's look at the bottom. Oh, well, that 4, that ain't going to change any. Minus, well, this 3x to the fourth becomes 0. So minus 0. So what are we left with? 0. There's our limit. We're approaching 0. Now, you might recall this from pre-cal. If the degree on bottom is larger, the horizontal asymptote is 0. This is saying that we have a horizontal asymptote at y equals 0. And that this is mathematically how we solve it. And you would get the same thing here. This just becomes 0 as well. Well, there is a shortcut for this. And I like to call this what matters the most. And this is really helpful for us. What matters the most? And what we really mean by that is if I were to take a look at this function right here. Let's take a look here. Let's look at this function. If I want to find out what really matters the most, I'm talking about as x gets really large, we want to make sense of what matters the most here. So another way I can look at it is I can look at the top of the function. I have this 3x squared minus 3x plus 7. Well, this is a parabola. Well, what determines the shape of the graph is that largest degree, is that 3x squared. So what matters the most here is this 3x squared. And on the bottom, same thing. This is a quartic graph, so it's that 4x to the fourth that makes the big difference for us. Another way to look at it, as x gets really large, here we have x squared, here we have x, here we have 7. As x gets really large, which one of these would grow the fastest? this 3x squared, which is why it becomes a parabola. Those get knocked out. That gets knocked out. So what I'm left with is the limit as x goes to negative infinity of 3x squared over 4x to the fourth. Now, we don't want to plug infinity right now because you would get infinity over infinity, and that's bad. We would get infinity over infinity, and we don't like that. Ew, yuck. So use algebra. Don't forget to copy your limits. As x goes to negative infinity, we would get 3 over 4x squared. In other words, we would get 3 over infinity if I were to plug that infinity in now. And we just said anything over infinity is basically 0. Right there. So there's our answer. So let's try that. Ready? If we look at number 1 here, we want to think, well, if I'm dealing with infinity, this is talking about a horizontal asymptote, so I want to think what matters most. So what matters most? Remember, we're just looking at the largest power degree. Look at the largest degree, top and bottom. So on top, the 2x matters the most, the 1 goes away. On the bottom, the 3x matters most, the 5 goes away. So I could write this as the limit as x goes to infinity of 2x over 3x. And again, don't plug infinity in. Every year somebody does this, 2 times infinity over 3 times infinity. Those cancel, and they get 2/3. That is wrong. Remember we talked about infinity cannot equal infinity. So we could simplify this. The x's cancel, I get 2/3. Again, don't leave your answer this way. We have to write out our answer, it's 2/3. So let's try number 2 here. Same idea. The 1 doesn't matter, only the 3x and the 4x squared matter. Everything else can just go away because I'm going to infinity. So this is saying that we have the limit as x goes to negative infinity. And if you're good at the algebra, we can always reduce it. This is 3 over 4x. And again, we are plugging this in. This is 3 over infinity, which is 0. So what we are saying is that we have a horizontal asymptote, y equals 0. This is saying we have a horizontal asymptote at y equals 2/3. Right there. When we get to number 3, you notice we have this absolute value. Well, hopefully you recall that the absolute value of x is just plus or minus x. So again, because I'm going to infinity, I don't need to worry about the 1 and the 3 because these matter the most. So when I rewrite it, I get the limit as x goes to infinity of 2x over this plus or minus x. Oh no, we can't have two answers, even though the x's cancel out. So I'm either going to get plus or minus 2. So my choice is I either get plus or minus 2 right here. Because remember, the x's cancel out. That's just my constant rule. But the question is, well, which one do we pick? The positive or the negative? Well, to do that, we look at the infinity. I'm approaching positive infinity. So we're going to pick the positive 2. And that is because x is going to positive infinity. So therefore, the answer is just positive 2. Likewise, if we get to a problem like number 4 down here, again, that's plus or minus x. Well, that's plus or minus x right there. So I could rewrite this as the limit as x goes to negative infinity. Again, infinity, so I'm not worried about the 1 or the 3. And I'm going to get 2x over plus or minus x. Now again, the x's cancel, so I'm going to get plus or minus 2 right here. But which one do we pick? We want the negative. We want the negative 2 because our limit goes to negative infinity, so we get negative 2 here. And the same is true for number 5. Oh no, we're still going to infinity right here. There's a war over it, right? I saw the movies. So I don't care about the 3, it just goes away. So I could rewrite this as the limit as x goes to infinity of 2x over the square root of x squared. Well, hopefully remember from earlier that the square root of x squared is just plus or minus x. So I can rewrite this as the limit as x goes to infinity. And you notice it's the exact same as the last one. So which one do I pick? We pick the positive. So again, the x's cancel, so I'm left with plus or minus 2. We pick the positive, so the answer is just 2. Right there. Number 6, exact same way. Except for this time we're going to negative infinity. So we would get the limit as x goes to negative infinity. And the 3 doesn't matter any. So we would get 2x over the square root of x squared. But again, this is plus or minus x. So we would get limit as x goes to negative infinity of 2x over plus or minus x. X's cancel. So again, I get plus or minus 2. Which one do we pick? Pick the negative. So our answer here is going to be negative 2. Very easy to do those. Pause it if you need to. Watch the video again. Like it. Smash that like button. All right. Special cases. Now last year, now notice, over here I always did what matters the most. There are other techniques for it, but I always try to do the same technique every time. So no matter what happens, I get the right answer. So this is again looking for a horizontal asymptote. But you might recall in pre-cal that if the top is bigger than the bottom, there is a slant asymptote. The problem is that's not specific enough for calculus. We want to know what's happening to the function. To solve this, we're again look at what matters the most. And again, on top we got the 2x cubed, the bottom we have the x. So we would get the limit as x goes to infinity of 2x cubed over x. And if I simplify this, I get the limit as x goes to infinity of 2x squared. If I plug in, remember this is 2 times infinity squared, we get infinity. So in other words, this is a slant asymptote, but it's really a parabola. So this has a parabolic asymptote, not necessarily like a linear asymptote like we're used to in pre-cal. But what it's saying is that as x goes to infinity, this is going to infinity here. So let's try number 1 right here. Same idea. I'm going to infinity, so I'm looking for horizontal asymptote. So those don't matter none. So this says the limit as x goes to positive infinity. And again, if you're good at algebra, you can reduce this. 3x over 5. And if you plug in, we got 3 times infinity over 5. We don't ever really write that. We just think it. But we know that that's going to become, again, positive infinity. Remember last year when you had to find slant asymptote? Right? Most kids might remember that. To find the slant asymptote, you had to divide. This is a quick way. A quick slant asymptote is just to look at what matters most. So we can say the slant asymptote is 3/5 x. Right there. And if you think about that, it kind of looks like this. There's my slant asymptote. And yeah, as x continues, this goes up to positive infinity. It is increasing without bound. Or increases without bound. For number 2, again, those don't matter because we're going to infinity, right? The limit as x goes to negative infinity. Now we already don't need to reinvent the wheel. We already have that one, 3x over 5. And if I plug it in, I get 3 times negative infinity over 5. Notice I don't put that on my workspace because AP doesn't like that. Okay, because you really can't take 3 times infinity and get anything. It's an undefined value, so we don't like to say this equals infinity or whatever. But in our mind, we can think about that. So this is negative infinity right there. All right. So because 3 times the negative infinity will become negative infinity. So I hope you guys enjoyed the video. Smash that like button and don't forget to subscribe. Ring the bell icon, whatever. I don't know, whatever those YouTubers say. I'll see you guys later.